Our next guest is coming all the way from Berlin. We have a very warm relationship here with Berlin as well. Karsten, Renke, Colin. Karsten, we still have the walls, unfortunately, here in Belfast, but I was in Berlin when you had the walls, and I've been there since they came down. You're a Glasgow headquartered company, a Greco, recently bought over by private equity. You're in the generation of power at large scale. So if we're going to find a solution to climate change, Karsten, someone's going to have to find a way to power mines, to power large industrial operations. And Karsten, you have an absolutely magnificent title because you are the Director of Future Technologies. That's what we say, no pressure, Karsten. But look, it's great to have a Greco with us all the way from Berlin. Guten Morgen, guten Abend. The floor is yours, Karsten. Thank you for being with us.
Thank you, Martin. Thank you for having me. It's an absolute pleasure. So I guess in my session, I want to talk about some of the challenges that the industrial energy users face when they want to decarbonize the energy supply, just as Martin mentioned in the introduction. And why joining forces of different players in the value chain, so from technology companies, which we heard of just before, fuel infrastructure and supply chain operators and adjacent industrial users is so crucial to manage the challenge that we have. Given the role that I have at Agreco and the various touch points that temporary power services have with industrial energy users, I will use Agreco's business as a running example. But at all means, please feel encouraged to think of Agreco or temporary power as a placeholder for adjacent industries such as aviation, shipping and transportation, or production of chemical goods. So if we could go to the first slide, I'd like to take a look on what industrial energy users are characterized by. So what are the requirements that make it hard to abate their energy supply? As a first step, let's have a look at temporary power, and then I'll take some more general observations. In temporary power, we serve many industrial sectors with various applications and requirements. Some of them I put here on the slide as examples, and we do this globally in more than 90 countries. We have customers that require industrial scale and high-grade power in remote locations where there is no infrastructure in place, like in the top left and the top right for oil and gas customers or mining customers, or where the existing infrastructure cannot cope with their needs, like in the utility sector on the bottom left, where we provide bridging power in emerging economies, or for seasonal peaks in petrochemical and refinery, or for temporary needs in events, like in the Tokyo Olympics just right now, or construction sites. Our customers may need the solution for weeks or years, for fixed loads or seasonal loads, with planning ahead for very complex projects, or without much planning in emergency situations. We will have to deploy the solution in Siberia or the Sahara. We may have the luxury of vast amount of spare land around the facility, so we could maybe even use something like photovoltaic power, or ideally, we will need to deploy something at zero footprint on a city center construction site. All customers have in common that power is critical to their mission, and they prioritize reliability, availability, and cost very highly. And so to fulfill all these sets of requirements, and there are more actually, but just let's focus on them, the temporary power industry landed on using liquid hydrocarbon fuels, so mainly fossil diesel. And that's an energy carrier that is stored and moved to the point where it's required and then converted to electricity by a quite flexible and comparably efficient internal combustion engine, the diesel engine. So that's where we are today. And it is a quite complex scenario in which a low emission alternative needs to prove itself. And that's why it makes this industry so hard to abate. And I bet this sounds quite familiar to other industries as well. And that's probably because you have similar requirements and constraints to work with. It all starts with the scale of the demand that is very typical for an industrial user. We're not talking about 90 kilowatt hours of stored energy in an electric vehicle to move around in an urban setting, but we talk about megawatt hours and gigawatt hours of annual energy or feedstock equivalent demand, and consequently also tens and hundreds of megawatts of power that are needed on site. And these high amount of energy needs to be brought to the point of use, because typically on-site generation will not be possible. Then it needs to be stored at site and converted to the form of energy you need. In our case, it's mostly electricity, but it can be propulsion for a maritime or heavy-duty transport application. It can be cold, heat, whatever you need. So fundamentally, fuels as a means of energy storage and the conversion back to power play a key role. And historically, of course, it was the easiest to use fossil sources, because in the fossil case, the energy that is stored in the fuel is already stored in the crude that we pump out of the oil field. The second requirement that is quite crucial for industry users are cost and reliability. Industrial processes cannot afford downtimes. As for heavy energy users, competitiveness is also tied to the cost of energy and its reliability. And therefore, adopting costly and non-proven technology is an absolute no-go for most industrial customers. So if you think about a petrochemical or a refining site as depicted in the middle of the slide, for which we provide cooling services during service periods or seasonal demands, but you can also think of refueling times of planes, trucks, the amount of space a fuel takes on a ship, and so on. And this also has an immediate impact on the risk appetite in terms of technology adoption. Large-scale processes, especially in highly competitive and commoditized industries, are cost-optimized end-to-end, and they also have rather long investment cycles. And as a third requirement, you often find that the global availability of a fuel as a commodity is in need. Global industries needs global solutions. When it comes to fuels, that means that you need to be able to access fuels as a commodity at viable pricing wherever the industry needs to produce or service its customers. So an attractive supply chain is a key enabler for any alternative fuel that we want to use. And maybe a last requirement to highlight is operational readiness. Large operations involve the capability of its people. So not only your technical processes and the operations have been optimized and centered around your current energy source or feedstocks that you're using, but also your operational readiness as an organization through the people that you are. So in essence, the challenge that energy-hungry industries face is to find ways to bring renewable energy to the site of use while carrying their investments in processes, infrastructure, and people forward without risking production, competitiveness, and therefore survive. So ideally, the easiest way to do that would be to change just the fuel for something that is carbon neutral. So let's have a look at the next slide and to see what is out there as option as alternative fuels. Again, keep in mind that you as a business have invested in your fleet, your production process, your infrastructure, and you just want to decarbonize. So in the first step, an industrial user will probably draw up something like a table on this slide. You will define your baseline supply. So what your processes are running right now. And in this case, it's for businesses running on liquid hydrocarbon fuels like gasoline, diesel, HFO if you're more in Africa, or kerosene in aviation. You then look at the different alternatives you can categorize. You categorize them according to their impact on your existing investments. Drop-in means use directly as is, or with some minor modification of your existing processes and training for your people. Non-drop-in means the opposite. Let's have a look at this obviously non-exhaustive table. There's much more out there. Biofuels are made from biogenic source feedstocks, obviously. E-fuels, we have heard from them also from David before, are made from renewable energy, electrolysis, and then you need a carbon source like just presented by Climeworks. So the carbon is sequestered in the fuel when it's produced, so the same amount of carbon is only released when it's combusted. So in theory, net zero. Fossil fuels in this list also include conventionally sourced hydrogen, as it's made from natural gas, and waste gases. Let's remind ourselves what we need to understand when we look at these alternatives. It's the feasibility and reliability as a solution for the customer or the industry we're working in, the global availability as a commodity, and of course, the total economics. This is why I put some colored boxes around them, clearly from just my limited point of view. Let's start on the top with the biofuels. The second generation biofuels like HVO or HEFA, they work great with today's engines and turbines in aviation. They are true drop-in fuels, unlike the first generation FAME. However, all biofuels face some challenges on the feedstock. whether it's food crops, land use change, the palm oil content, or the availability of the used cooking or waste fats that are needed to produce them. So while they are working great with some of the technologies out there today, and they're growing in volume in terms of the supply chain, there are some doubts on my side, on our side, to the scalability to a truly global supply chain under sustainable constraints. Closely related to the biofuels are the e-fuels, as David also covered earlier today. So instead of the biogenic carbon source, you use captured CO2. You then need to produce a lot of hydrogen and then establish some chemical processes like the Fischer-Tropsch process to produce synthetic carbon neutral fuels. So that's great because it's fundamentally net zero and you can keep all your beloved and existing assets. Perfect. But unfortunately for this pathway, we need almost free renewable energy and a vast amount of green hydrogen available before this can happen. So long-term it is. The same applies to green hydrogen, which is also very hard to store and transport, by the way, and related hydrogen carriers such as green ammonia or green methanol. If you can use renewable energy directly, like depicted here on the slide as a solar plant, do it. Locally generated, locally used is the best you can do. And then there's natural gas, a 15% lower carbon intense fossil fuel when compared to fossil diesel, but with some additional complexity around storage, energy density, and the way to convert it back to power. But it is available today as a commodity, and it is the first step to reduce emission. So what's my message from this observation to you? In my view, there is no silver bullet available today. We also need to mind the timelines and the availabilities of the alternatives. We have seen that at the e-fuels. They could help greatly with net zero for energy intensive usage, but will not arrive before the hydrogen economy unfolds. And while we cannot just wait for them to arrive, we should also not disregard this pathway and throw away everything we know of using these fuels. Don't mix fossil descent with a particular fuel as an energy storage. We have reliable, efficient, and cheap conversion technologies that can deliver low carbon power if the fuel is not fossil. And then hydrogen is not the answer to every challenge. It's a great starting point for many pathways, but not an easy direct fuel. And lastly, the availability of alternatives is often outside the control of the industrial user itself. So at this point, it's probably a good idea to look at something that we as an industrial user can control more directly than the availability of alternative fuels. Let's look at the next slide. So while investments in fuel lie outside our control, it's not our core business, we cannot just wait and see. We as an industrial user need to take a closer look on how we can expedite the transition to cleaner solutions. We have a responsibility to do so. And we have to build the demand via technologies that work in our industries. We can and must act as partners that help to expedite the development of these technologies that we need. Unfortunately, and I think we've heard that, or we got a glimpse of that before from Neustark and Kleinbergs, energy technology development involves hardware development. That means it takes time, a lot of money, and carries risk. And this is depicted here on the slide as a usual journey of a technology through its different readiness levels. For those who are familiar with the TILs, you know what I'm talking about. And it goes from knowledge development over technology development to commercialization of the technology, and then eventually to customer adoption as a mature tech. So let's remind ourselves what realistic timelines look like from a technology, from an initial thought of to arrive in mass production. You can think as an example, a new battery technology or some new technology, as we just heard, that helps us to capture carbon dioxide. And anyone who has done hardware technology development knows that the first 10 years are easily spent to get something working at a lab scale. If you then have enough funds and you don't have too many hurdles to overcome, you may be able to build a small-scale demonstration system in 3 to 5 years' time. This also means, of course, already you have to think about how to manufacture your technology as a product rather than just a technology. You have to redesign to get some cost out and use as much over-the-shelf components that you can find. You enter the market, some early adopters will buy, and hence your product and technology matures. If you have enough revenue and you make it to around 15 years from inception, industrial users start to look at it. They love mature tech, so they will wait until others have adopted enough of it. So they would normally wait for an OEM, like an engine OEM, to develop a new engine generation before putting it into their own products. So let's say a generator in our example. So we're looking at 15 to 20 years before a technology scales at industrial use. But of course, to meet our emission reduction targets as a global we need to be faster. So what we need and can do as an industrial user, in my view? Let's start with the funding. We need more funding for hardware startups. Software is great, but it will not solve all the problems. We need investors with the appetite to fund the longer, more cash-intensive hardware technology startups that we just heard about. And I come across many of them struggling in Europe to find the right kind of funding. On the industrial side, we need a higher risk appetite to help to sort things out quickly. We need to scale up technologies which are less mature earlier into our businesses than under the classic model before. With this, we help to de-risk the VC investment into these early technologies by acting as a strategic customer. And we need to offer the route to market to validate technologies quickly, because while we heard startups are super smart, they're efficient in trialing and quickly turn new ideas around, they often struggle to understand what the market really needs and what the customer requirements look like. We also need to partner with lead customers to bring minimal viable products to the field rather than just the mature products and wait. And together, we need to identify overlaps with adjacent industries and sectors. Leveraging each other's interest is important to build the demand in technology and then also the alternative fuels to enable the investments we also desperately need. So the main message, of course, is we need to partner, partner, partner. And to wrap up the session with something more tangible, I wanted to give you some examples on my next slide. 3 partnerships that we in Agreco have founded or built to follow this more conceptual approach on the previous slide and make it, turn it into life. So you see 3 different kind of technologies. One is a hydrogen monocombustion generator on the left-hand side. In the middle is a methanol engine-enabled generating set. And then there's airborne wind on the right-hand side. And we've partnered with rather non-typical technology partners to build these demonstrators. For hydrogen combustion, we work with CMB Tech, which is the technology arm of the Belgian shipping company CMB. And CMB Tech itself has its roots as an engine tuner, so not really an industrial supplier of engines that would normally work with us. For methanol, we are working with Scandinavians, a Swedish naval architect with an extended experience in methanol-enabled propulsion engines. In both cases, we use Agreco's existing generator products to take what's working well in the field, swapping the diesel for something else, diesel engine, and to accelerate the feasibility testing with our lead customers. So we're not just waiting for the OEMs to do their investment to figure out if there's enough volume and what the right technology is, but we're partnering with people that have moved in earlier so we can support the learning on what will work in our industry and what won't. A slightly different approach story is our partnership with TwinTech on the right-hand side. That's airborne wind. And they don't have an existing tangible product, so we couldn't bring it to the field. But they have a proof of concept, and instead of waiting for them to go through the whole development cycle, we partnered with them to carry out a fairly detailed techno-economic analysis of their technology in our business model. And this analysis helped us to understand how big the potential of the technology is and help them to understand how a product would need to look like to be relevant for us as a strategic customer. And that's all even before the design of the first product prototype has even started. And with these examples of partnerships, I thank you all for your attention, and back to you, Martin.
Carsten, Renke, Colin, Director of Future Technologies in Agreco in Berlin. Our warm greetings to Berlin this morning. You're the first representative of Germany. You won't be the last before we're finished. We wish you well. We have heard from many small companies this morning. You're the largest company we have heard from, but of course we need the large companies to get engaged. So very pragmatic. I hope it wasn't a pessimistic presentation. You said 15 years, very pragmatic, clear-eyed, and you're getting it done, Carsten, please God. So,
Thanks, Martin.
So thank you. Tschüss. Schön, tschüss.
Cheers. Bye-bye.